Alright, today we will be reviewing how to graph systems of linear equations. Again, this is to help us out once we start graphing systems of linear and quadratic equations. Systems of linear equations, as you can see here, can have three different outcomes. You can have no solution, that's where these two lines never cross. You can have one solution, down here where they cross at exactly 1 point. Or you can have infinite solutions where the lines actually overlap each other. So let's go ahead and look at our first example. I have f of x equals negative 1/2 x minus 2, and g of x equals negative 3x plus 3. I'm going to be graphing f of x in blue. For f of x, I see that my slope is negative 1/2, and my y-intercept is at the point 0, negative 2. So I'm going to start there at negative 2, and I'm going to use my slope of negative 1/2 to go down 1 and to the right 2. Okay, those are going to be my 2 points for f of x, and I will connect them with a line. Then I have g of x. I'm going to graph that in green. G of x, the slope is negative 3 over 1, and my y-intercept is at the point 0, 3. So I'm going to start there at 0, 3. And my slope tells me I'm going to go down 3 spaces and to the right 1. And if you notice, these systems of equations, or this system of equations, has one intersecting point, which is right here. And the coordinate point for this is 2, negative 3. Yep, to the right 2 and down 3. So that would be our point of intersection is at 2, negative 3. So this would be a system with one solution. Okay, example 2, f of x equals x minus 3. This is going to be in blue. There is a 1 out in front of that x, so that's going to be my slope, 1 over 1. My y-intercept is going to be 0, negative 3. So I'm going to start there, and I'm going to use my slope to go up 1 over 1. And then g of x, my slope is negative 3. My y-intercept is 0, 1. So I'm going to start at 0, 1, and I'm going to go down 1, 2, 3, and to the right 1. And as you can see, I do have one point of intersection, which would be here at the point 1, negative 2. And that's going to be my point of intersection. Example 3, I have f of x equals 2x plus 1 and g of x equals 2x plus 3. F of x, my slope is 2 over 1, and my y-intercept is 0, 1. For g of x, my slope is 2 over 1, and my y-intercept is 0, 3. So I'm going to start at 0, 3, 1, 2, 3, and I'm going to go up 2 over 1. And as you can see, my graphs will never cross. They are parallel because the slopes are the same. Since the slopes are the same, like I said, they're never going to cross, so this would actually have no solution because there's no POI, no point of intersection. Example 4, I have g of x equals negative 4x minus 1. Here my slope is at negative 4 over 1. My y-intercept is 0, negative 1. So I'm going to start at 0, negative 1, and I'm going to go down 1, 2, 3, 4 to the right 1. That's going to be my graph of g of x. F of x is going to have a slope of negative 1 over 1, and it doesn't actually have a y-intercept, so you can say that's plus 0. That means our y-intercept would be at the point 0, 0, so at the origin. And my slope tells me I'm going to go down 1 and to the right 1. Oops. And if I connect these lines. Now here it's kind of hard to tell where your graphs intersect, so you might have to solve this algebraically. In this case, what you would do is just take g of x and f of x and set them equal to each other. So you'd have negative 4x minus 1 equals negative x, and you would just try and solve for a point. So I'm going to add 4x to both sides. This makes x's positive. I have negative 1 equals 3x. Then I'm going to divide both sides by 3 to get x equals negative 1/3. And once I know x equals negative 1/3, I'm going to take it and plug it back into f of x, so that I can say y equals negative x. And since I know that x is negative 1/3, I can plug that in. So negative 1/3. This would mean that y equals positive 1/3. And this would get me the point of intersection of negative 1/3, comma, positive 1/3. So you won't always be able to tell graphically what your point of intersection is, but if that does happen, you can always solve it algebraically. And that is how you graph systems of linear equations.